Welcome to School Quiz. Again, this side Anjali Singh, and we'll continue with the topic momentum. Okay, so I'll continue with the sharing slide. Yes, we studied up to the formula that is A is equals to F by M, where F is the force which is exerted on an object, whereas M is the mass of an object. Now, I described this formula also. Sorry. I described this formula also, where F is directly proportional to the acceleration, where M is the inversely proportional to this acceleration. Here, if the mass is half, you can see student here, suppose I'll start with mass with doubles, okay? If the mass of the body is double, now tell me, here, if the mass of the body is doubles, it means it will be 2m. Then what will be the acceleration? Acceleration, that's really important. Acceleration will be F by 2m. It means it is half of F by m. Means acceleration, okay, acceleration is half. Why? Because the mass got doubles and the relation is inversely proportional. Whereas the acceleration, now the mass is half. Now this is the first condition. I'll derive the second condition. Now suppose the mass is half, means by 2. That's really important. Okay. Acceleration is F by mass is half. So this will be 2F by m. Or you will write 2F by F by m. Means here the acceleration is double. Here the acceleration is double. Clear? So in this case, acceleration is half, where the mass is double, because it's following the inversely proportional relation. Okay, and if I'll talk about the force, if the force get double, if the force is double, then what it will be? A is equals to 2F by m. Means acceleration is also double. This is the first case. If I'll talk about second case, where the force is half. Okay, then what it will be? F by, okay, so that will be acceleration is what? Half. Because it follows the directly proportional relationship. Clear? And here it inversely proportional relationship. Clear? I think that's clear to you. Okay, since the acceleration produce, okay, that's only written here. Okay, that is only written here, that which will be increasing, then which will be decreasing. So let's see. We'll move to the further. Yes. Now, you can see this cricketer. When the batsman hits the ball and this fielder trying to catch the ball. So what this fielders do? He is trying to lower his hands. He is not catching the ball like this. He is always catching the ball like this. He or she, now the girls are star cricketer. Okay. So he or she will be catching the ball like this. Why? So that the force will be lesser on his hand. Force applied by the ball on the cricketer's hand will be lesser and lesser. The fielder moves back his hand gradually on catching the fast cricket ball to reduce the momentum more gently. Here the momentum will be more gently. Okay, means the mass as well as the mass will remain same. You know, mass can never be changed. What will be change here? Velocity. When the fielder lowers his or her hands, so the velocity will get slower and slower. This case also, this is here also, the fielder will be less injured. Okay, it prevent his hand from the injury. Clear? Now, cause of a higher jump. Yes, here you can see this athlete, a heap of sand, being a soft and the fluid like, reduces a large momentum of a falling high jump athlete more gently. Suppose if this athlete, you have always seen these athletes are running before jumping. Why they are running actually? If they will directly go to the finish point and they will start jump. So then what will happen? In that case, they will not they will not cover the longer distance. Why? You can see this, during athlete meet, a high jumping athlete is provided either a cushion or a heap of sand on ground to fall. Okay, it means here, if they will run, it means they acquire the velocity. If they will run, it means they acquire the velocity to cover a longer distance. Means their velocity will get increased when they are ready to jump. And here it is written, why sand is provided when they are directly landed. Okay, why like clean floor is not there? Because sand. Yeah, that's really important that I have to explain. Here the sand will take the more time. Sand will take the more time. More time means, na, in case of karate player, I said more time means less force. Okay, sand will take the, or you can say sand will cover the more time to reach the athlete to contact with the ground. That is why less force is exerted. Here, this is what can happen if the passenger do not wear seat belt while traveling on a car and the car stops suddenly due to an accident. Large force, small time, large force is acting. They are inversely proportional to large force on the body of the passenger produced by rapid decrease in momentum. Okay, can throw the passenger forward violently, causing serious injury. Here also, less time, it means more force. That is why this passenger got injured. That is why it is advisable. It is advisable everyone to wear the seat belt. Okay, these all are the car provided with the seat belt for the passenger to prevent injury in case of an accident. As well as, yes, I think I'll take the, no, helmet case is not applicable here, I think. Yeah, here you can see mass 600 kg. The man is applying force, okay, to start this car. Here, less force is exerting in comparison to this big car, which has a mass 2600. More mass, more force has to apply to change its position. Clear? To change its position. Now, I think this is understood to you. And everyone knows, that's already discussed, SI unit of force is Newton. Okay. So here, So here, you know, if I have to derive this force, 1 Newton force is derived with 1 kg of mass is having an acceleration of 1 meter per second. Clear? So the first law of motion discussed earlier, in fact, a special case of second law, because when the applied force is 0. Okay, I think now I already delivered a more and more topic that I will discuss later. What happened? Why we are going to relate with the first law to the second law. Okay. So student, I think this is enough for you. Student, give your time to read all this as well as read the first law of motion also, as well as read the second law of motion also. Okay, with the relation, that is, yeah, the relation is momentum, whereas in this p is equals to mv, where m is the mass and v is the velocity. You know, when the quantity will increase, so that the another quantity will decrease. So that I had given you to today. So please everyone, read this and revise this. Till then, goodbye everyone. Bye bye.